Now we'll move on to create a 5D simulation. As I've mentioned before, this simulation builds on the 4D simulation by adding a new dimension, cost. To begin, let's create a new page in Power BI. One way to do this is by returning to the page that contains the 3D viewer and duplicating it. This gives us a clean starting point with some of the setup already in place. Once duplicated, we can start organizing our 5D report. The first thing I'm going to do, just like I did with the 4D simulation, is add a title and the company logo. Power BI lets you copy and paste elements, so I'll simply select the logo, copy it, come to this new page, and paste it. The logo is now in place. I'll do the same with the title and update the name of this page to 5D simulation. Next, for the time dimension, I'll bring in two visuals, a timeline and the play button visual we used earlier. Remember, the play button lets us visualize the construction process over time. I'll repeat the same steps I followed in the 4D simulation, but now as part of our 5D setup. With those elements in place, it's time to focus on visuals for our fifth dimension, cost. First, I'll create a table that shows detailed information about each element. I'll start by adding the 4D task ID. Then I'll include the quantity for each element, followed by the unit so we know whether that quantity refers to area, volume, or another measurement. Next, I'll add the unit cost. This is where we introduce the cost dimension. Right after that, I'll include the total or final cost, which is calculated as unit cost times quantity. To complete this table, I'll also add the start date. Remember, if the date shows up split into year, quarter, month, and day, just right-click on it and select the flat date format. And finally, I'll add the end date. Now that we've built the table, we have a complete summary of all the key information about the elements in our report. We can see the quantity, the unit of measurement, the unit cost, and the final price. We also have the start date and the end date for each element. Once this table is in place, we can begin adding visuals focused specifically on the cost dimension. The first visual I'm going to create is a column chart, and this will help us visualize the cash flow of our project, essentially showing how the budget should be allocated over time as construction progresses. To build this chart, I'll place the start date on the x-axis. To make sure it's formatted correctly, I'll right-click the field and select the standard date format. Then, for the y-axis, I'll use the final price. Now we can see a visual representation of how funds should be invested as time advances across the duration of the project. In addition to generating visuals and adding the required data, Power BI also allows us to customize the appearance of each element. For example, we can change the title, adjust font sizes, or tweak many other visual properties from the Formatting tab. In this case, I'll go ahead and change the title of the chart to Cash Flow so that it's clear what this visual is showing. Now let's add another visual that will show us the cumulative cost of our project. For this, we're going to use an area chart. The data we'll use on the x-axis will once again be the start date, and on the y-axis, we'll use the final price. As you can see, this chart displays how costs accumulate throughout the course of the project as it progresses over time. Within this same visual, we also have the option to add a secondary y-axis. This is useful, for example, if we have data about the actual costs the project has incurred so far. We can place that on the secondary axis and compare the planned budget against the real expenses. This allows us to apply different project control techniques, such as earned value analysis. Once again, we can go into the Formatting panel and update the title of the chart to make it clear that this visual represents the cumulative cost of the project. Now let's add a visual that shows us which elements of the project are generating the highest costs. For this, I'm going to use a visual called a tree map. It's very useful for visualizing proportions within a data set. In the Category field, we'll place the 4D task ID, and in the Values field, we'll place the final price. As you can see, the tree map is now showing us that the elements with a 4D task ID of 1002 are contributing the most to the total cost. This corresponds to the large slab located in the school park area. Other high-cost items include the elements with task ID 105, which represent the masonry walls for the classrooms. In this way, we can quickly identify which elements are responsible for the largest portions of the budget and understand how costs are distributed across the different components of the project. To wrap up, I'm going to add one final visual that will allow us to analyze our project according to the month of execution we're interested in. This visual is called the button slicer. It's a filter that lets us interactively choose what we want to display on the screen based on a specific data point. In this case, we're going to use the start date of construction activities as our filtering criteria, and we'll configure the slicer to group this information by month. This way, for example, if we select the month of June, all the visuals in our report will automatically update to reflect only the data relevant to that month. We'll be able to see which elements are scheduled for construction during June, the quantities of those elements, the total cost for that month broken down by each component, the start and end dates of those tasks, the cumulative cost up to that point in the project, the cash flow for the month, and the timeline that shows exactly what is being built in June. We'll also be able to see which elements are generating the highest cost for that month. And with that, we've completed our 5D simulation, which, as we've seen, includes the dimension of time through the project schedule and the dimension of cost, which is tracked over the course of that schedule. As we've demonstrated, Power BI provides a wide variety of visuals that let us present and analyze our project information in ways that are aligned with the decisions we need to make. In this case, we created both a 4D and a 5D simulation. But the same methodology could be used to generate other types of reports as well, such as clash detection summaries, or any kind of analysis that responds to a specific project or company requirement. And don't forget that if the visuals shown here aren't exactly what you need, you can always explore the Power BI marketplace to find and add new ones that better fit your needs. Finally, keep in mind that these reports can be fully customized to reflect your company's branding. From the formatting pane, you can change the background of the report, add company colors, and tailor the layout to your visual identity. For instance, here we have a more polished version of the same report using Rodzer's branding. Each visual includes a title to clearly explain what information is being shown, making the report more accessible and professional. Once your reports are ready and include all the visuals you need to analyze the project, it's very likely that some of the data will change over time as the project progresses. A common example is the start and end dates for construction activities. It's also possible that you might want to add entirely new types of data to the report later on. Fortunately, this is very easy to manage using the Rodzer database. To do this, return to the Google Sheets file where we've been managing all the data included in our report. If you need to update any existing information, you can do it manually. For example, I'll go to the Custom Properties tab and update the start date for elements with the 4D task ID 91, which refers to the columns. Let's imagine something happened on site and the construction of this element got delayed. Instead of starting when originally planned, it will now begin on March 28th, a 1-week delay. In addition to this update, let's say I want to add a new variable, something like the contractor responsible for each group of elements. In that case, I can simply add a new column in the Custom Properties tab and enter the contractor name or identifier for each task. Remember, all additional information you want to see reflected in your Power BI report needs to be included in the pivot table, because that's the sheet that gets imported into Power BI. So let's check our update. We can see that for all elements. With a 4D task ID of 91, the start date has now been updated to March 28th. Great. Now we just need to add that contractor column to the pivot table. As you might remember, the variables we previously added, like quantity and final price, were calculated manually, but others are pulled using formulas that reference the Custom Properties tab. To maintain that connection and make it easier to drag formulas across, it's important to insert new columns right after column L. That way, we don't break any existing formulas. Once we've added the new contractor column, we can drag the formulas from the previous column, and the values will be imported automatically from the Custom Properties tab. And with that, assuming all your new data and updates are ready, we're now set to return to our Power BI report and continue working with the updated information. Now, to refresh the data in Power BI, all you need to do is click the Refresh Data button. That's it. Just one click. Once you do that, Rodzer will automatically compare the information that was already loaded into the report with the data in your Google Sheets database. If it detects any changes, it will update those values. And if it finds any new data that has been added, it will import that as well. So let's take a look. If we scroll down in our table to the elements with 4D task ID 91, we can now see that the start and end dates for construction have been updated to March 28th, just like we changed in the database. On the other hand, if we go to our pivot table, we can also see that there's now a new column with the contractor information we added. Let's say I want to display that new data in our report. I just add it to the table where we're showing information for each element. And now, alongside the unit value, final cost, and the construction dates, we can also see the contractor field that we added directly from the database. This ability to either update existing data or add new information to a Power BI report using a simple, user-friendly database like Google Sheets is something only Rodzer currently offers in the market of this type of software. As you can see, we just go into the database, and using the formulas already set up in that sheet, we can manipulate the information very easily and very clearly without needing to use complex formulas or programming languages like DAX, which would normally be required inside Power BI. Now, having built a detailed report with all the data needed to ensure the proper execution of a project is already a major step. But it's just as important to be able to share that information with your team. So, in the next video, we'll show you how to share this report online so that everyone on your team can access it, visualize the data, and clearly understand the metrics being used to drive project decisions.